Welcome. We're going to do task 5.8, but we're going to do the second triangle, and this is a generalization from what you did on the first. So you're going to follow the same process, but here you don't have any values, you just have variables. But you'll notice the process is the same. So again, they're asking for any triangle, how can you find an area given angles A, B, and C, given side lengths, opposite side lengths at A, B, and C? How do you find that area? So what's a formula you could use? And so if we follow the same process, we start with the law of sine. Sine of A over A is equal to sine of B over B. And that gives us a expression for A. This is the base. Using algebra here, solving for A, we get B times the sine of A over the sine of B. So the first thing I'm going to do is I'm going to write this down below because we've just figured out what that A value is here. So it's B sine of A over sine of B. I know it says B, that's B standing for base, but the base here is A is actually the variable, just to confuse things. And then also we can find the height here using the sine function. So the sine of B, opposite over hypotenuse, h over c, algebraically this simplifies to h is equal to c times the sine of B. So now I'm going to add that c times the sine of B, and then of course I also have times 1/2, because all triangles have an area of base times height divided by 2. Now algebraically I can simplify this. I notice there is a sine B here and a sine B here, so that'll simplify. So what I end up with is BC sine of A over 2. So if that looks familiar, it's because BC divided by 2, right, kind of looks like base times height divided by 2, but you're multiplying it by the sine of A, and that's the adjustment that you'd want to make for that. So it'd be 1/2 BC times the sine of A.